This video is your review of Strand 5 of the SOL workbook, and we're beginning on page 73 with SOL 7.10 A through E. This standard asks you to represent relationships with tables, graphs, rules, and words. Determine the slope of proportional linear relationships and the y-intercept of non-proportional linear relationships. So just as a brief overview, function is a relationship between values where every input has exactly one output y. So when two quantities x and y vary so that one is a constant multiple of the other, then the two quantities are proportional. Proportional relationships will always pass through the origin at 0, 0. We use the form y equals mx to represent those proportional relationships where m is our slope. So the slope is being multiplied by x every time to get the y value of that point. Slope can also represent the rate of change of a proportional relationship between two quantities. So if you're finding the slope, you're looking for the change in y over the change in x, or the vertical change over the horizontal change, and most commonly we hear it as rise over run. So a set of ordered pairs can be written as xy, and it can be shown in a table like this. So when we're talking about finding the slope, we can just figure out what the slope is by looking at the rise over run. So we can find two good points on the graph, and we can find the rise, which is 1, over the run, which is 2. So think about rise, we go up. Think about the sun rising, it comes up into the sky, so it's how far are you moving up and down. Whereas run, you can only run horizontally on a flat surface, so we're running horizontal, that's how many we go over side to side. So our rise was 1 and our run is 2, and that's the most simplified we can make that number, so that would mean that the slope of this line was 1/2. The equation of the line would then be y equals 1/2 x. This graph was proportional because it went through the origin at 0, 0. And then the other way you could have found the slope here would be to do y over x from the table. And if we check both of them, we have 1 over 2 and then 2 over 4. They're both equal to 1/2, which means that this is going to be a proportional relationship, so we can just say right away that we'll know the slope is 1/2. Now, sometimes sometimes functions are not proportional, and they're going to not go through the origin. That means they're going to have a y-intercept, and that's going to be the result of adding a quantity every time to x to get y. And the y-intercept is going to be where the line crosses our y-axis. So the point of the y-intercept is where x is 0, and that point B is going to be where it crosses the y-axis. So our additive relationships will not be proportional because their graphs won't cross through the origin. The y-intercept can be positive or negative. If it's positive, we write it like this, y equals x plus b, where b is that y-intercept. If it's negative, we write y equals x minus b, where b is still the y-intercept, but if it has a negative sign there, then that means it's a negative value. So as an example of this one, if we have a table where Thomas is 4 years older than his sister Amanda, we can see that whenever Amanda is 4, we add 4 to her age to get Thomas's age, which would be 8. When Amanda is 5, Thomas is 9. When Amanda is 6, Thomas is 10. And when Amanda is 11, Thomas will be 15. So we're just adding 4 to those ages. So we can write this in a table of x and y. So we have 4 to 8, 5, 9, 6, 10, and 11, 15. To figure out the y-intercept, we do y minus x here. We can check all of our y minus x. 8 minus 4 is 4, 9 minus 5 is 4, 10 minus 6 is 4, and 15 minus 11 is 4. So that means our y-intercept here is going to be 4. That means that we can say the y-intercept is 4. It's crossing through this y-axis at 4 here. We can put the rest of our points from the table right onto this graph to get our line. And then we can connect it to get that graph of the line. But to write it in the form that we talked about up top was y equals x plus 4 right here. The b is our y-intercept. We just figured out it was 4, and that's how we can fill in the equation there. So the last thing you kind of need to remember for functions is they'll give you points and they'll say, is this on the line of this equation? So if I give you the point 6, 2, and we want to test to see if it's on the line y equals 1/3 x, we take this and we plug the point into it. So 6, 2 just means that x is 6 and y will be 2. So I'm putting a 2 in where my y was, the equal sign comes down, 1/3 comes down, and then we're multiplying by x, which was 6. So I do 1/3 times 6 is 2. that equals 2, so yes, this point would be on our line. If we have the point 4, 2, and we're trying to see if it's on the line of 1/3 x, we do the same thing. X is 4 and y is 2. So I put a 2 in where y was, equals 1/3 times our x value, this time is 4. 1/3 times 4 is 4/3. That is not equal to 2, so this point would not be on our line for this equation. We're going to move on to page 81 to talk about SOL 7.11, and that's that the students will evaluate algebraic expressions for the given replacement of variables. So you just have some review of important vocab here. Remember, a variable is a letter or symbol used to represent something we don't know. An algebraic expression doesn't include an equal sign, whereas an equation does include an equal sign. A term is just a real number, a variable, or a product of real numbers and variables. So we have 3x, we have 2, and we have 8. Constants are specifically terms that don't contain a variable. So up here, when we had 3x, 2, and 8, 2 would have been a constant, and 8 would have been a constant. We have the coefficient, which is a number that's multiplied by the variable in an algebraic expression, and it's always placed to the left of the variable. So when we have 3x, 3 is your coefficient. Finally, an exponent is just the number of times you have to multiply a number by itself. So if I have 3x squared, the little 2 up top is the exponent. That means that x would have to be multiplied by itself 2 times in order to get the answer there. So when you're doing this unit, we need to make sure that we remember the order of operations, or GEMDAS. So you start always with your groupings first. So that's parentheses, brackets, or these curly Q lines here. We also have exponents, which is when you have to calculate your exponents, you need to multiply them by themselves. So start with your groupings and your parentheses, braces, or brackets, and then you have your exponents where you're multiplying them by themselves. Then we go to our multiplication and division. So any multiplication and division that you have, you just have to complete it from left to right. Finally, the last thing you do is your addition and your subtraction. So anything that's left with addition and subtraction, go from left to right. So all we have to do for something like this problem where we have 3c plus 8 minus c minus 2 for when c equals 3, what we're going to do is take 3 and put it in everywhere we see c. So 3c means 3 times 3 plus 8 minus c, which is 3, so we put a 3 in, minus 2. So all I did in this first step was put c in, or replace 3 for c. Then we follow GEMDAS. Now we don't have any exponents here, we don't have any groupings, we just have multiplication, addition, and subtraction. So we start with multiplication. 3 times 3 is 9, our plus sign comes down, 8 minus 3 minus 2, everything else comes down. Now all we have left is addition and subtraction, so we just have to go from left to right. So I start with 9 plus 8, that gets me 17, everything else comes down. Then I do 17 minus 3, which gets me 14, minus 2. Last step to get us 12 is our final answer. In the next problem, we have 4 times the quantity of x minus y, where x is 3 and y is negative 1. So we plug in a 3 for x and a negative 1 for y. So my 4 and my parentheses come down. 3 was x. My subtraction sign comes down from the problem, but I'm replacing y with a negative 1, so I have another negative sign in there. First thing I need to do to evaluate this is to start with my groupings, because I do have parentheses here. So 3 minus negative 1, remember when you have minus a negative, that just turns into a big plus sign. So we have 3 plus 1 in our parentheses. We finish what's in the parentheses by doing 3 plus 1, which is 4. And then my last step is 4 times 4, which is 16. Remember, when you have a number next to parentheses, we're just multiplying. So it just means 3 times 2 if you see something like this. We're going to move into our next SOL, which is SOL 7.12 on page 86. And this is our SOL all about solving two-step linear equations with one variable. So the whole goal of solving an equation is to find the value of the variable. You're solving for x, you're solving for c, you're solving for u. Whatever your variable is, you want to get it by itself so that you know what it equals. So to do that, you need to look for the side with the variable and determine what the constant is. We'll use addition or subtraction to get rid of the constant on both sides. Once we do this, then we can use multiplication or division to cancel what is attached to the variable. We get the variable by itself, and then we can check our answer by evaluating the original equation with our solution. So in the first problem, we have p plus 3 equals 5. We look on the side with the variable, and our constant is the number that does not include a variable. So we subtract 3 from both sides. Positive 3 and negative 3 are opposites, so they go away, and we just have p left over. Equal sign comes down, and 5 minus 3 is 2. That means that p equals 2 is our final answer, and all we have to do is just fill in 2 where we had p in this original problem. So if I put a 2 in where p was, 2 plus 3 should equal 5. 2 plus 3 is 5. 5 equals 5 is true. That means we got the right answer. In number 2, we have 30 equals 5u. 5 is being multiplied by the variable, so the opposite of that would be to divide. 5 divided by 5 is 1, so it goes away, which means we have 1u, and u comes down by itself. 30 divided by 5 is 6, so 6 equals u. Plug in 6 for u in the original problem. 5 times 6 is 30. 30 equals 30, so we were correct. That's the right answer. We have k minus 6 equals negative 1. We look on the side with the variable, and our constant is negative 6. We get rid of it by adding 6 to both sides. Those are opposites, so we are just left with k. Negative 1 plus 6 gets us 5. So we check it by putting in 5 minus 6 should equal negative 1, and it does, so that was the correct answer. The last problem, we have 7 equals 1/2 c. So we're multiplying c by 1/2. So you can either divide by 1/2 on both sides, or you can multiply by the reciprocal. So we're just multiplying by 2 over 1 here. When we do that, we're just left with c, because we get 1/2 times 2 over 1 just equals 2 divided by 2, which is 1, which gives us just 1c, or c, which is what we're looking for. On the other side, we have 2 times 7, which is 14. So 14 should be our answer. If we plug it in for c in that original problem, 1/2 times 14 gets us 7, which is a true statement. So c equals 14 was our correct answer. So that's for our one-step equations. Following two-step equations with that, it's the same idea. We're just looking for constants first, and then we use our multiplication and division. So it's kind of like using the order of operations, but backwards. So we start with subtraction and addition, then go to division and multiplication, and then take care of anything else that we have left over. So we're going to use inverse operations to get it by the variable by itself. I have 2x plus 7 equals 15. I just focus on the side with the variable and get rid of my constant. The constant is the number without a variable, and my constant here is positive 7. Opposite of positive 7 is negative 7, so those are opposites. And then I'm left with 2x on that side. 15 minus 7 gets us 8, so we have 2x equals 8. We treat this like a one-step equation. Right now x is being multiplied by 2, so the opposite of that would be to divide by 2, and that gets us x equals 4. We check this by plugging in 4 for x, so I go back to my original problem where I had 2 times 4 plus 7 should equal 15. Following GEMDAS, 2 times 4 is 8, 8 plus 7 is 15. So this is true, and we had a correct answer. Our last SOL to review is SOL 7.13, and it tells you that the student will solve 1- and 2-step linear equations in one variable, including practical problems involving addition, subtraction, multiplication, and division, as well as graphing the solution on a number line. So this is on page 92 of our workbook. When you're graphing inequalities, you need to remember the open circle versus a closed circle. You have open circle when you're given the less than or greater than symbols, and you use the less than or equal to or greater than or equal to with a closed circle. Because it can be equal to it, we color it in. If it can't be equal to it, we leave it open. So when we have graph the solution of -5 is greater than y, remember our lowest numbers are down here on the left of our number line, whereas our greatest numbers are to the right. Graphing the solution of this, -5 is our number, so that's where we put our circle. And since we don't have a line under our greater than symbol, it's not filled in here. It's an open circle. Now y is our variable. It's touching the little side of our symbol. So we have the little side touching y. That means we need to go towards the little numbers or the lowest numbers, and that's why we shade to the left here. When you're solving an inequality, it's the same exact steps as when we were solving equations. Now, the only thing that's different is that if you multiply or divide both sides by a negative number, you must flip the direction of your inequality sign. So in this example, we have x plus 4 is greater than or equal to 9. To solve this, we subtract 4 from both sides. That gets rid of our 4's, and we have x is greater than or equal to 5. So if you check it, you could try a number that's greater than 5. A number that's greater than 5 is 6. So if we plug that into the original problem, 6 plus 4 is 10, and 10 is greater than or equal to 9. So that's true. We could graph our solution there, and this number line is actually graphed incorrectly, so let's change that. If we have x is greater than or equal to 5, we need to circle on 5, and then x is greater than that, so we can shade anywhere to the right there. Now, just to do a quick practice with a negative, we could have negative 2x is greater than 10. If I'm solving this inequality, I would divide both sides by a negative. If you divide or multiply both sides by a negative, you must flip the sign of your inequality. So when I do this, I get x is less than negative 5. Notice that I had to flip the direction that my inequality was facing. Now, to graph this on a number line, I would need my circle on negative 5, and it would have to be an open circle because I don't have an or equal to part under this, and x needs to be less than negative 5. That little side is touching my x, so I have to shade to the left here. And then that would be the graph of this solution.